Hi everyone. So in this video we're going to look at homework 8 and how to solve it. So as a heads up for those who didn't look at the email yet, um, I'm giving everyone 5% extra since it took a little longer than it normally should have. So just as a quick heads up, so everyone got 5%. Um, Everyone who did it. So let's break down this problem. I know it was difficult for most people, I think. Um, but I think a lot of this is because, I think I mentioned this a few times, correlation basically just uses everything we've learned in class. So if you don't know everything kind of fairly well, then you're gonna have some problems doing it. Um, so let's kind of break it down and see what the method of doing this is, and what to kind of do. So first off, the question is asking, so in order to receive all your presents, P.S. I hope you enjoyed the storyline. It was fun creating it. So yeah. Anyway, hopefully the surprise at the end was not too bad. Anyway, so in order to receive all your presents, first we assume that x and y are two random variables. We suppose that y is exponential with mean 423. And we suppose that when x is conditional on y, it is exponential with mean y. Um, so here we ask, what is the correlation of x and y? So we want to know the correlation of x and y. So here we're trying to solve correlation of x and y. So here, if you remember, by definition, this is just the covariance of x and y divided by the standard deviation of x times the standard deviation of y. So this covariance, if you remember as well, this is just expected value of x times y minus the expected value of x times the expected value of y divided by these two standard deviations. So one thing that should be fairly easy to solve right away is the expected value of y. So we're told that the expected value of y, or we're told that, that the expected value of y, the mean, is 423. So we know that the expected value of y is 423. So that's easy. And since it's exponential, we also know that the standard deviation of y is 423. So remember for exponential, the expected value is equal to the standard deviation. All right, so nice and easy. And then we're also told that x and y, when x is conditional on y, it's exponential with mean y. So in other words, the expected value of x conditioned on y equals y is equal to y. So what this is also telling me, just by the same things as above, that the standard deviation is also equal to y. So what does this give us? Well, what we know is that the expected value of x, so here, this is going to give us the expected value of x, right? And the reason why we can kind of see that is we're looking at this x here, right? Like we have the y done. So the next one we would usually try to do is the x. So the way to kind of do this x is look at this x here and notice, oh, I can just use my law of total expectation because I already have an x in front. So here, law of total expectation, e of x given y. And here the thing to note is that remember that when we have one function equal to some other function, we can just substitute. So we can just substitute these in. And e of y we already know. This is 423. So we're almost like we've done 3 out of 5 things. There's 2 left. The expected value of xy and the standard deviation of x. So we'll kind of go in order of difficulty. We'll start off with e of xy. So e of xy, I think everyone kind of has seen how to do this trick now a few times from class. Again, we're going to use law of total expectation. And we cut by y. we look at 8 with regards to y. And in this case, the reason why I'm doing y is because I want to keep this x given y quantity. Because x given y we know. We don't really know y given x. So the reason why I do given y is because now I can actually pull out this other y, right? E of y, e of x given y. And this we went over class. We went over it in class. We went over it in problem sessions. I've done this a few times. So if you don't understand why this is the case, then definitely look at those videos. And then this one we just saw above, right? So this is just e of y. So we have e of y squared. So now the question is, well, what's e of y squared? Well, that's actually not too hard to solve because we actually already know the standard deviation. So if we look at the standard deviation of y, remember that this is just the square root of the variance, which is actually just e of y squared, which is the thing we don't know, minus e of y squared. Now this and this we do know, right? We know both of these. So in other words, what we have is 423 squared is equal to e of y squared minus 423 squared. So in other words, I can bring this 423 to the other side. So e of y squared is just 2 times 423 squared. So that's it. So this we can plug in here. And we get that e of xy is equal to 2 times 423 squared. And I'm going to leave it like that for now in order to not kind of worry myself. Okay, so the next thing we kind of have to solve, so let's see, this is done as well. And the next thing we kind of have to solve is SD of x, right? So this is the only thing that's left. So how do we solve SD of x? Well, we're going to run into the same problem, right? So SD of x, in this case, we have something that's a little more difficult, right? Because we don't know, we know what e of x is, right? This we know, but we don't know neither SD of x and we don't know e of x squared, right? Because we don't know the distribution of x. But what we do know is x given y, right? So we can try to do something similar to this. And this is basically what we're going to kind of do. So basically, let's figure out, so basically what we want to do is look at something similar to this, but I need an x squared. So how does x squared kind of fit in? Well, if I do x squared, let's just do the same mentality or the same trick that we have here, but we'll do it with our conditional probability. So let me first do it for a particular case, and then we can expand it, right? So this is one function. So I'll just go straight into this kind of side step here. So remember, this is only defined on random variables, right? So I can't put in, so I can't put in x given y, right? SD of x given y doesn't make sense in this case. So here, what I get is x squared given y equals y minus e of x given y equals y squared. And here the reason why this is beneficial is because we know that we already know these two things, right? It's exponential, so we already know what this is. So here on the left we have y, and on the right we have, well, I guess I'll just do the y squared right away. On the right we end up having the formula we want, minus y squared. So in other words, the expected value of x squared given y equals y is equal to 2y squared. Now we just convert this into our expected values. So in other words, what I'm basically saying is, what is this? Well, this, right, is equal to this. So we have 2 this is thing, so it's 2y squared. We need a capital because we need random variables. And here we can actually then use this to help solve for this here, right? Because now we can just use the law of total expectation again. Oops. Right? But now we know what this inside thing is, so we can just put it in. We can bring out the 2, and we get y squared. And we already solved this. E of y squared, right? We already know what this is. It's up here. So it's 2 times 423 squared. 2 times 423 squared. Okay. So far so good. But we're still not done, right? Because we're trying to solve this SD of x. So what's SD? SD of x. Well, this is the square root of e of x squared, which is 2 times 2 times 4. So I'll do this. 2 squared times 423 squared minus e of x squared. So what's e of x? E of x, if we recall, where's e of x? Here's e of x. E of x is 423. So it's minus 423 squared. Here, you can kind of see I have the 423 twice, so I can pull out the 423 if I want. And then I will have 2 squared minus 1. So this is just 423 times square root of 3. So that's the standard deviation of x. Okay, nice. We're almost done. Now at this point, we just need to solve. X, y, we have all our variables. E of xy minus e of x, e of y, divided by sd of x, sd of y. So first, this is a y. So e of xy, this is, where did I put this? E of xy is here. So we get this is equal to 2 423 squared. 2 times 423 squared. E of x was just equal to e of y. Yeah, e of x was equal to e of y, which is 423. So we actually get just 423 squared here as well. Divided by 423 square root of 3. Times sd of y, which is 423. So here we get 2 minus 1, 423 squared. On the bottom, I get 423 squared times square root of 3, which is equal to 1 over square root of 3. And that is our final answer. So as I know there was a lot, oops, you can't see because of my head. Can I move this up? I'll just hold it here. So as I know there was a lot of debate in Discord, as some people were telling me whether everyone got the same answer or not. As you can kind of see, yes, everyone should have gotten the same answer, even though your numbers were different. And that's one of the reasons I kind of chose this. I wanted to do something where it's like a little more fun, where it's like, oh, you all get the same answer, even though your initial inputs are different. Because I know sometimes people are like, wait, if we're not using this number, why does it matter? And here you can kind of see that using numbers are very important. So yeah, so as you can see, that's it. It's not too difficult. As long as it's basically just using the same thing over and over and over. The main two properties we used was law of total expectation. Maybe I should highlight these. The main things we basically used was the law of total expectation, right? And then we just used this, we just used this property a few times, right? That we can just look at the standard deviation using the variance, and we can calculate it that way. And that was it. So at the end of the day, I think the hard part was just putting everything together. Because as you can see, we used a lot of different information from different areas. So yeah, so that's it. This video will end here. If there's any questions, feel free to ask. I put my office hours for the final exam in the email. If there's any questions, feel free to ask. So I will see everyone, some people on Sunday. If not, have a good rest of life. And I hope you enjoy the rest of everything you do ever. All right. Bye.